Welcome to Keller's Coder, and today we got a computer that mind reads.
My testicles reveal to me that it is a red card. Is that correct? Your card is the 2 of hearts.
What the fuck? Motherfucker! So about 4 months ago I got an email from the University of Belarus whether I wanted to take part in a body language study. They would ask me questions online, film my responses, and I had to answer perfectly honest.
Have you ever used a glory hole? Please answer honestly.
Yes. And lie at certain questions.
Did you or do you engage in intercourse with animals? Please lie.
I did that. I didn't hear anything, so I figured, well, that's a waste of time. They don't want me as a research project. Now, the other day I got the model sent in and the software. I already loaded the model and the software. And they told me to get a packet of cards, pick a card at random, then look at it, and then answer a few simple questions, and it could deduce the card from that. So I'm curious. So I'm doing this in a continuous shot so that it doesn't look any suspicious or weird, because, you know, cards and card tricks, for me that is always synonymous. Bad magicians. So I got the app loaded. Now, let's pick a card. I won't show it to the screen. I don't know what they did. Keep it away from the screen, from the camera. Can they see the bottom? No, they can't see the bottom either. So. Okay, let's start the app. Tell us, computer, which card am I holding?
My spider sense tells me that it is a red card. Is that correct?
Correct.
Is the card that you are holding a diamond?
That is correct.
Your card can only be the Queen of Diamonds.
What the fuck? Now tell me, computer, which card am I holding?
My neurons tell me it is a black card. Is that correct?
Yes, it is.
Is the card that you are holding a club?
Yes.
Your card must be the 5 of clubs.
What the fuck?
Please put the card back on top. And then give me a number between 1 and 52.
7.
Count down 7 cards and you find the 10 of spades.
What? 1, 2, 3, 4, 5, 6. I'll be fucking damned. What the hell is this? Witch! Witch! Burn on the stake! Burn on the stake! Fuck me. Now the astute of you may have realized that this is not a body language AI. Luckily there still is no such a thing. It is basically a very simple state engine and a magic trick. I used to be a performing mentalist and stage hypnotist about 10 years ago. And through that I became an engineer creating effects for TV shows. For example, the next Uri Geller, which was called Phenomenon in America. There it flopped. The next Uri Geller in the Netherlands ran 3 seasons. And they did a spin-off Mindbusters that I also contributed to. And what I usually did was I created very technical effects. Usually mentalists use very analog effects like cards, peaks, hidden writing, etc. I would use advanced electronics and computer programs to do that, and that would actually fool the magicians, the mentalists as well, and that was initially what I really liked about that, misleading them. What this is basically a 2-person code. I used to do this with another mentalist. He would be the plant or I would be the plant, and they would pick a card and I would mind read, or they would mind read. And the thing is, it is all in what the mentalist, in this case me, is saying. The computer is just fishing for information and I'm feeding it the information. So for example, I cut the cards. And I come to that in a moment why I cut the cards, not shuffle the cards. I pick a random card and this is the 9 of hearts. Now listen how I signal this. Tell me, which card am I holding? Tell me. Now, for example, the next card would be a diamond. Tell us which card I'm holding. There is the nuance. Tell me, tell us. If it is a spade, I would say, now tell us. And if it is a club, I would say, now tell me. So by those first couple of words, the computer is already ahead of the audience. It knows the suit, and by implication it knows the color. So it can innocently ask me, I feel that the color is black. Is that correct? That correct is a question that allows me as the feeder to answer. And I answer in 4 different ways. I answer in yes, yes it is, correct, or that is correct. And what that does is it will signify 4 blocks of cards. Each block 4 cards. So the first block, yes, will contain ace, 2, 3, 4. The second block, yes it is, will contain 5, 6, 7 and 8. The third block, correct, will contain 9, 10, jack, queen. And the last block, that is correct, will contain the king. And I just for easiness, it's king, king, king. Because we only have 13 cards. Then it will ask me if it is a club. I can sense it is a club. Is that correct? Now I again will answer in one of these 4 answers to indicate where in that block that card is. So if it is, for example, this is the 8 of clubs. The first answer on the color is yes it is, 5, 6, 7, 8. And then it will say it's a club, isn't it? Or is that correct? And then I will answer with that is correct. That is the last number in that block, 5, 6, 7, 8. It's the 4th position. And that is how I am feeding the computer the information. Now how does it know which card is on which position? Well, and that is an ancient card trick method. These cards are so old they don't fan nicely anymore. There we go. It is a Stebbins stack. It's a cyclical stack. Any cyclical stack will work. Now what is a Stebbins stack? You have every card is alternated clubs, hearts, spades, diamonds, and it's 3 higher than the previous card, and it wraps around. So the cool thing is you can have a spectator cut the card, take the card sight unseen. I now have peeked that the bottom card is the 8 of diamonds, so I add 3, 8, 9, 10, jack, diamonds, clubs, hearts, spades, diamonds, clubs. So the next card that they have picked must be the jack of clubs. And since it's cyclical, it wraps around, it's very easy for the computer that has a whole array of this 52 cards stack to tell me what is on that position. And that is basically it. It's very simple. Let's jump in the code and have a look. So here is that stack. In Magic we have card codes and cards. A card code is AC, Ace of Clubs, QS, Queen of Spades, 4S, 4 of Spades, and a card is the 4 of Spades. And that is important because I have a handful of methods that would convert card codes to cards and cards to card codes. And their individual parts, of course, are individual functions. I don't like big functions, I like functions that only do one thing. Then we have a placeholder for the card that is chosen, where the computer will fill in all the information it gets from me. So the color in the suit is the first that is being filled in with the first sentence that I speak. Now tell us, which card am I holding? Indicating it's a spade, and a spade is by definition black. Then we go to the main. I removed my subscription code. Here I basically just set up the speech recognition and the speech synthesis. I use Azure for that. I have an Azure subscription for this, that's why I cleaned it out. But I think even that the speech recognition and the speech generation is actually free. I have not checked into that. I have a running subscription on Azure, but I think it's actually free. But just to be certain, I removed my code if it isn't. But you can set up an account, run this on your laptop, it will be so much fun. So I create the speech synthesizer, the speech recognizer, and we go into an infinite state engine loop. And we call the definition, we get into that. It will set the text that I've spoken. It will set the current state. So we start by getting the color and the suit, that's the first state. It passes in that card placeholder and it passes in the stack that we want to use. The reason I pass in the stack is that there are different stacks, some that are not as easily detectable as the size 7 stack. If you're interested in that, just research mentalism stacks, and there are some card stacks that if you fan them out or you just put the cards down, it just doesn't look like there is a predictable cyclical stack in there. And it's also good practice to always have something parameterized that you can change it without having to go into the logic. I write the output to the screen, I speak the output to the speaker, and I recognize my voice in it. So basically we're looping around in that state engine. Let's go to the state engine. This is definition, that is basically the state engine that we keep calling, and it calls the different states. So we start by get color and suit, because that is the first sentence that I say, and I reset the card from the previous example. It's not really necessary because we fill them in, but I like a clean system, and it reduces potential errors. And then we do the get color function, and that get color function will advance to the next stage, get value range, I believe. So get color, and here you see it's just basically string parsing. It looks very complex, but it's just string parsing. That's all what this is. So we have hearts, diamonds, clubs and spades. These are the sentences. Now the astute of you may wonder why I didn't do this. Start with tell us and now tell me. Sorry. Because that would make sense. The problem is that sometimes the recognizer recognizes still a part of the other sentence that is spoken. So I do a partial match. Now a partial match for the astute of you will realize that the order of the if block is important. We first need to check those that have the now in there, because if we would first match the tell me or the tell us, it would match and it would give the wrong card. So the order of these matching blocks is important. We just fill the placeholder with the information that we have. We advance to the next step, get value range, and return the text that the infinite loop is speaking out. And I have some different things like my testicles reveal to me that it is a red card. Is that correct? And If it doesn't recognize, it remains quiet. Well, we have to reset card, we set everything empty to 0, just a good practice. Then the next stage is get value range. We saw that also here, get value range. So we go to the get value range and it's just string parsing again. And here we're parsing the sentences that indicate which of the 4 values it is. Yes. Yes, it is, or sure it is. Correct. That is correct, or you are correct. No, in case the color is wrong, you can say no and it goes back to the get color and suit state. The reason for this little implementation is that sometimes you say the sentence when it just starts triggering and it loses the now, or it interprets the now as no. So you can just say, no, this is incorrect. And then it would say, sorry, let's try again. And you can basically feed again a new card in there. And even I, as a professional mentalist, sometimes have things wrong and you just admit, okay, it's wrong. It's an experiment. Experiments never go 100% right, so we do it again. And then we need to advance to the next stage, which is the get value. Conveniently, my code is always, well, mostly structured in the way that we go through the states. Get value, and again we have those same 4 sentences, which indicates the card in those 4 blocks. And the cool thing is that if it is a king, you can answer anything because it will match those 4 states. So you don't have to answer that is correct specific, yes, but you can answer that is correct as well. I hope that makes sense. And again, it's just string parsing, it's very simple. And we set the code block, etc. And then, well, here are all the helpers, the static functions that convert from card codes to cards, and from cards to card codes and their individual parts. I like to have small individual functions that do a single thing. And sometimes I even break my own religion, but I try to do that as much as possible. And then we get to the reveal card at position, which is the state called cyclic stack reveal. I should have called this cyclic stack reveal, but it doesn't really tell you a lot when you're a novice what it actually means. Reveal card at position. That's why I call it that. And basically it just finds the card in the cyclic stack, which is the card that is on top. So it finds the card that is on top in the cyclic stack, knows the offset, and then basically calculates by checking if it's larger than 51. Then we take the index, which is the card location in the stack, plus the number that we set, -1, because stack started 0. If it's larger, then we subtract 52, and otherwise it is the index. It's very, very simple. It is magically simple. But because it's all speech recognition and voice synthesis, it is, it looks more complex than it is. This is it. I can't make it any more difficult. The code is in the description. I hope you like this one, and I hope to see you in the next one.